Guys, tell me, am I audible right properly for everyone? Yes, thank you for your responses. Yes, good evening, Purva. Good evening, Jaini Kodagu. Good evening, Sri Devi. Yes. Good evening, Rajendra Reddy. Yes, thank you for your response in YouTube also. Okay, that's great. Good evening, Nikita. Okay, guys, in a general talk for 2 minutes. Okay, most probably we are going to complete the first chapter today, means electrostatics. Meanwhile, from tomorrow onwards, we are going to start about the electrostatics. Mein second part hai electric flux, and there we will introduce one more scientist, gas. Okay, and gas law we will study there, and then further potential kya hota hai? Potential kya hota hai na? Actually, in 11th standard, you people know when an object, actually object hai, okay, a place mein. If I'm going to bring this object from here to here, means position change ho gaya. Due to change in this position, there is an energy stored in this one. We call potential energy. How to write that potential energy for the charge? We will discuss that one in our next class. And then based on that electric flux and potential, we are going to discuss one beautiful application in our daily life, that is capacitor. Capacitor ही एक आधा chapter है, electric field and flux एक आधा chapter है. Okay, these are all the things which we are going to cover in a next part of the electrostatics. Right? I think it's a good time to start. One by one is coming. 5 o'clock also over. Okay, today in this class, basically we are going to discuss about the torque due to electric dipole, and then potential energy in which stored in a electric dipole. How the potential energy will be stored, we are going to discuss that one, and few good numericals also. Okay, tactic numericals. Okay, not too high numerical. They will give boost up our energy level. How we are study means how much we analyze this chapter. No, we need to know means if you go through this chapter numericals means it is enough. Okay, few only, not too much. Okay. Yes, good evening, Yashaswini. $14 members. Okay, we'll start, guys. Okay, बहुत ज़्यादा हो रहा है time. And then before starting actual topics, as usually we have to take a previous class review, means preview. Okay, last class, last point, actually I discussed the torque on a electric dipole, correct now, which is placed in a electric field. Right here what happened, just देखो, torque means इधर rotating force मैंने बोल दिया था, और किसके ऊपर, डाइपोल के ऊपर. डाइपोल मींस एज यूजुअली प्लस एंड माइनस क्यू चार्ज, दे आर सेपरेटेड विद अ स्मॉल डिस्टेंस एंड देयर डायरेक्शन विल बी ऑलवेज फ्रॉम नेगेटिव चार्ज टू पॉजिटिव चार्ज की तरफ होता है. ओके, एंड वी आर कीपिंग दिस डाइपोल इन एन एक्सटर्नल इलेक्ट्रिक फील्ड. व्हेन यू kept this dipole in an external electric field, no, on these two charges external electric field applies the force. Right, on this positive charge, as a property of charge, it will be acting in this direction, force. Correct now. On this negative charge, force is acting opposite direction. As I told you, it is an uniform electric field. Uniform means har ek jagah, if you take this electric field force at point A and electric field point at B and electric field point at C. Okay, all the point field intensity will be same होता है, उसको हम बोलते हैं uniform electric field. Clear? And then I told you that due to opposite charges and same amount of magnitude, net force value will become equal to 0. Net force value equals होता है. And then we discussed the torque also. Torque क्या होता है? Due to keeping this dipole in external field, ये क्या कर रहा है? देखो, this is a pen means ऐसा है dipole. At this point, force is acting along in this direction. At the bottom point, force is along in this direction. दोनों खींच रहे हैं, and this electric field tries to align this dipole along the electric field line. Like this, it will align. Means इसको rotate कर रहा है. Rotate कर रहा है means इधर एक force act हो रहा है. वो फोर्स को हम बोलते हैं इधर रोटेटिंग फोर्स को टॉर्क. क्लियर? नमस्कार. कोडगो हो रही है. ओके, एंड देन नेक्स्ट, yes, these two are coupling force. We can say coupling force. Actually coupling force is very simple. When you want to open the lid of the water bottle, what you will do, your thumb will be rotate the lid in backward direction and your forefinger will be rotate the lid in forward direction. Equal forces होता है but opposite direction में होता है. That is known as the coupling force. Due to this couple force, torque will be act on this one. Torque calculate करना है means we have a formula. Torque is equal to force into perpendicular distance. इधर force लग रहा है due to electrical force Q into E. That's why electrical force into perpendicular distance. मैंने बोल दिया perpendicular distance how to take. This is a dipole. Correct now? Dipole means angle theta. Okay, 2L along the x-axis means 2L cos theta, along the y-axis means 2L sin theta. Right? That's why we took here perpendicular distance means this is a perpendicular distance for the force. Okay, that's why we took here 2L sin theta as a perpendicular force and distance, and we got a equation Q into E 2L sin theta. Here 2L into Q. We call this one as an dipole momentum P and E sin theta. This is the torque equation. And finally, we write this one as an PE sin theta as an P cross E. P cross E means it is nothing but cross product of dipole momentum and as well as the electric field intensity. Okay, ये दोनों का cross product होता है torque. Okay, what is the direction of torque? If somebody will ask means how you will say direction of torque क्या होता है in this figure? Tell me in this figure only what is the direction of torque? Do you know how to say that, how to analyze the direction? Let me know. If you don't know means I will tell you. SI unit of torque will be Newton meter means इधर किधर हो गया torque. Okay, torque is equal to force into perpendicular distance. Force के लिए Newton and meter के लिए distance के लिए meter. This is the SI unit. Along the electric field torque. No Trupti. No. Actually देखो इधर this is the P means dipole momentum का direction है Q plus Q. Okay, and here electric field is acting along in this direction. Electric field means dipole momentum इधर है in this direction. मेरे कैमरा में देखो dipole momentum direction ऐसा है, electric field direction ऐसा है. Cross product means always we need to do screw rule. ऐसे पकड़ना है हाथ को, देखो मेरा हाथ. This is P incline. Electric field will be in this direction. Means just curl your fingers. Okay, thumb gives the direction of the torque. Okay, thumb gives direction of torque means electric field is in this direction. Okay, and then dipole momentum is in this direction. Plane means torque will be acting inwards. Inwards act होता है torque. Right? Yes, exactly right. Use right hand thumb rule or curl rule. Okay, देखो इधर P cross E plane में ले लो, कोई problem नहीं. P इधर है, cross कर लो. Cross means curling the finger to the next physical quantity. Thumb in which direction it will be gives the direction? No, that is the direction of the torque for all the cross products. Okay, for all the cross products. देखो इधर actually they show this one in a downward direction. Actually it is inwards. Okay, क्या है ये? Inwards. Clear? And then okay, this torque value when it is maximum, when it is minimum, we need to say Okay, that is also based on this equation. इधर देखो, ये इक्वेशन अब मैंने इधर लिख रहा हूं मैंने, टॉर्क इज इक्वल टू PE sin theta. Okay, torque is actually depending upon the theta value, how much it is aligning, not on the electric field. Electric field uniform means क्या जरूरत है, correct ना? All the points it will be uniform. Dipole momentum is dipole होता है when we took a charges, combination of charges, means charges will be constant. How much angle it is rotating based on that torque is dependent. Means here if I'm going to theta value will be 0. Theta value if I'm going to take 0 means what will be the torque? Tell me in a chat box. इधर एक मल्टीपल चॉइस क्वेश्चन आता है इसलिए पूछ रहा हूं मैंने, टॉर्क का वैल्यू क्या होता है when theta will be equal to 0? Put this value here. Good, Chandana. Krishna, Akshata, Ananya, Siddeshwar, talk is maximum. Bro, good. What I'm asking, what you are giving answer. Okay. What I ask actually, if theta value will be 0 along the electric field direction है, मान लो theta value 0 ले लो. Okay, that time what will be the torque? Torque value क्या होता है? Sin, देखो PE sin 0. Yes, Siddeshwar, right. Okay. Sin 0 है ना, sin 0 value 0 होता है, hence torque value will be 0. Means torque value minimum होता है when theta is equal to 0. That's it. That's it. Okay. In a similar way, let me know what is the maximum value of torque. Torque maximum कब हो सकता है? Yes, good. I need answer from each and everyone. I'm expecting the answer from each and everyone. फिल करो यार चैट बॉक्स में, कोई प्रॉब्लम नहीं, बहुत जगह है इसके अंदर. ओके, P sin theta. Yes, good. Good. Means theta value should be, sin में maximum कब हो सकता है? Theta value will become 90 degree. That time only torque will be maximum. Means torque value will become P into E. That's it. Clear है ना? ये दोनों में इक्वेशन में क्लियर, राइट? एंड वन मोर पॉइंट, इधर देखो, इफ केस इन थीटा वैल्यू विल बी 180 होता है ना, दैट टाइम आल्सो टॉर्क वैल्यू 0. sin 180 में अगेन ग्राफ ऑफ इट विल कम, देखो sin 0 इट विल बी हियर, sin 90 मैक्सिमम, sin 180 अगेन मिनिमम. हियर अगेन द वैल्यू विल बी 0 होता है. sin 270 में -1 बट इन ऑपोजिट डायरेक्शन मैक्सिमम. अगेन sin 360 में 0 होता है, मींस वन कंप्लीट राउंड होता है. क्लियर है ना? ऐसे हाँ, एग्जामिनेशन में यही होता है. व्हाट वी विल डू यूजुअली, वी नो sin 0 एंड sin 90, रट्टा मार लो, जाओ एग्जाम को. इफ दे आस्किंग व्हाट अबाउट 270 मींस क्या करना है उस समय? P होता है बट अलोंग विद द साइन माइनस P होता है, बिकॉज 270 में मैक्सिमम ही है बट ऑपोजिट डायरेक्शन में है इधर. Correct ना? Be careful. Good. I think everything is understood. To for everyone it is understood. Okay. And then also we discussed about the electric field intensity due to dipole at an axial point. For an axial point we got an equation 2p divided by 4 pi epsilon into x cube. Also we can write this one as an k 2p divided by x cube. Right. And in equatorial point we got k into p by, this is when we solve this one, no, actually L value we took 0, that time we got the value of electric field intensity k p divided by x cube. Okay, and comparing these two equation, equatorial line में electric field intensity, whatever the electric field intensity होता है ना, उसका आधा, half of electric field intensity will be present here, right? That is enough. This is half, or else you may write like this also. Electric field intensity at equatorial point, sorry, axial point will be equal to 2 times of the electric field intensity at equatorial point. This is also you know, right? Clear up? Last class का है सब कुछ. And then everything is understood means, let me know guys, let me know here what is the correct answer for this question. here electric field intensity E due to an electric field dipole varies with a distance r of the point from the center of the dipole as how the electric field intensity due to dipole which is varies with respect to distance. We are going to far away from the center of the dipoles. How it is varying. These are all the powers. Actually, these are all the powers, guys. Power means r square, r cube, r to the power of 4. Reciprocals. Which is the correct option? सिंपल सा क्वेश्चन है, ज्यादा मत थिंक करना है. Swapnil, good bro. Sorry, I'm giving late response in YouTube. Good Rituja, good Yashaswini. कहाँ गया सब लोग? अनन्या, अनुषा, जैनवी कोडगु, इंपना, निरंजना, PD. Who is this PD? ऋतुजा, सादिक, सागर, सिद्धेश्वर. कहाँ गया ब्रो? ये लोग बुटरेला. Yes, right. हाँ, सिद्धेश्वरा, चेक करो एक बार. Cool. Dipole के लिए इलेक्ट्रिक फील्ड इंटेंसिटी क्या आ गया था? This is minus Q. This is plus Q. Okay. At axial point or wherever you go, we got electric field intensity value is proportional to K Q by X cube लिखा था मैंने. इधर X cube is nothing but R. In terms of R they given. Okay. And meanwhile here electric field intensity is inversely proportional to X cube. X cube is nothing but R cube होता है. Correct answer will be B. Due to dipole here they are asking. Here they are asking due to dipole. If you go through the first class means force के लिए equation लिखे थे हम. F is equal to K Q1 Q2 by R square. In this force actually it is proportional to, means inversely proportional to square. Force is square. Okay. And the electric field intensity भी पता था हमको for a single point charge. Okay. For a single point charge के लिए क्या आ गया था? K cube by R square आ गया था. R square और R? R only. K cube by R. चेक करो एक बार. R square, sorry. R square means electric field intensity also inversely proportional to R square. This is for single charge. This is for single charge. Here they are asking actually dipole. Dipole means X cube will come. Clear enough? Tell me in the chat box. Yes, come. Impana right. Saga right, bro. Dipole. Good. If it is clear means I have one more question. What is the correct answer for this question? Question read karo properly. Okay. At a given distance from the center of a dipole, the field intensity on an axial line is K times the field intensity on the equatorial line. This is field. Just a minute. क्या होगा इधर? हाँ. Hey, good. Good, Trupti. Well tried. Good, Yashaswini. Means correct option will be B. 2 times. Now only I told. Clear enough? We'll start today's topic. I think everything is clear, right? Previous class का सब कुछ clear है ना? We'll start the today's topic. Let me know in a chat box. How was the Josh? खत्म हो गया sir. Don't tell me like that. Okay. Very high. Good. Keep it. Okay, we'll start a new topic, that is work done on an electric dipole in a uniform electric field. एक क्या है work done? सब कुछ बोलता हूँ मैं. Do you know what is work done, guys? Work done क्या होता है? देखो इधर. पहले मैंने 11th का analogy देता हूँ मैंने. देखो, this is a mass m which is placed on some surface. Okay, if I'm applying some external force means क्या होता है? It has sufficient force means this is a place A. Object will be moved to the another place called B. B के ऊपर जाता है, means it will be displaced in this direction to the applied force. Displacement हो गया, correct ना? Here displacement हो गया due to the force. We call this one as an work is done. Clear ना? Work done calculate करने के लिए formula P बताता है हमको. Yes, good guys, everyone. Work done will be equal to force into displacement. Sorry, it's a dot product. Force F dot S. Okay, no need to write anything. Just you think like that. Force into displacement. I will explain later. Force into displacement हो गया. Okay, this is called work done. Done हो गया work after displacing somewhere else. In a similar way, we need to analyze the work done for a dipole in an external field. क्या बोल रहे सर तुम? देखो इधर. Again we need to take a dipoles. Dipole का बारे में सब कुछ बोल दिया मैंने. एक नेगेटिव चार्ज, एक पॉजिटिव चार्ज, दोनों सेपरेट होना चाहिए, थोड़ा डिस्टेंस. Okay, where we need to keep the dipole? In an external electric field. Yes, done. Actually, in an external field, I kept this dipole already in some angle theta. मान लो ये theta angle से orient हो गया है. This is the original angle theta. मान लो it's a standard angle उसके लिए. Okay, on this dipole, what I will do? I will apply a small amount of force. Okay, these are the force which are applied by the electric field that trying to align this dipole in a electric field along the electric field like this. If it is like this, means they will try like this. Okay, what I will do now, it is with angle theta like this. Now I will apply a force on this dipole in this direction to move this one a small angle d theta. Small angle d theta move करता हूं मैंने. Means it will be moved with the applied force. Means shall I say here work is done? Can I say like that? Work done. बोल सकता है ना मैं? बोलो चैट बॉक्स में. गुड. अरे यार बोल दो ना, बहुत स्पेस है चैट बॉक्स में. मैंने बोल दिया ऑलरेडी. आई टोल्ड यू ऑलरेडी. In chat box there is an enormous amount of space is there. You can put all the messages there. Okay, yeah, good. कोई problem नहीं. If I done this one, no, you can follow this notes afterwards also. कोई problem नहीं. I will send the notes in a drive. Okay, देखो इधर. I apply the force. It is moved at a distance or angle d theta. Okay, now we need to calculate the what is the work done happened here. Okay, we'll go one by one. Total theta will be, second one will be theta 2. First theta is theta 1. After moving a small amount of d theta from the original axis, the angle will be 2 theta. Second theta, this one. Okay, we'll calculate the work done. Work done means हमको already पता है work done is equal to force into displacement. Again it came force into displacement. Okay, work done always scalar quantity. We can't represent this one in a vector quantity. Either small angle d theta is takes place no displacement, right? For that displacement, how much work will be done? Only small amount of work done, that is dw. Small amount of theta is displaced means small amount of work is done, correct na? That's why if I write this dw, okay, force hai, it is mechanical force, linear force. But here for this case, to rotate the dipole, what kind of force we need to take? Rotating force we need to take. Rotating force क्या होता है? Torque होता है. Torque into displacement कितना हो गया? d theta amount of displacement हो गया. Yes, Yashaswini, right. Write down d theta. This is what the work done. From here only we need to calculate. That's why I took like this. dw amount of work is done when it is displaced with a small angle d theta due to the torque applying on it. That is our d theta. Clear now? Work done, force into displacement only, right? Good. We'll go further. हमको ऑलरेडी पता है टॉर्क क्या होता है. टॉर्क इज इक्वल टू PE sin थीटा, करेक्ट ना? ये टॉर्क को इसके अंदर सब्स्टिट्यूट करो. टॉर्क सब्स्टिट्यूट करो इधर. आफ्टर सब्स्टिट्यूटिंग द टॉर्क विल गेट टॉर्क का प्लेस में PE sin theta d theta as it's common, and work done will be small amount of work done dw. Okay, small amount of work done. Okay, done. If I apply the force, if I'm applying the force to rotate this dipole from here to here, बहुत ज़्यादा rotate करता हूँ मैंने. At that time, we need to find out total work done. Means what we need to do? We need to add all this d theta, d theta, d theta, and how much work done will become dw, 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 dw amount of work done. Instead of that one, yes, in a simple way, what we will do? Yes, Trupti, yes, Yashaswini, good. We'll do here integration. Both the side integration kar rahe hain, right? That's it. If I integrate the dw, no, then we will get w, total work done. And integrate करना है, किधर से किधर तक करना है भाई, ये क्वांटिटी को उसको भी जानना पड़ता है. क्या है ना, इधर देखो, ओके देखो, this is first angle theta 1, correct ना, and we move this one with the angle d theta, means this is a second angle. For here only I am saying that theta 2 means theta 1 से theta 2 तक इंटीग्रेट करना है. क्लियर है ना, सिंपल सा बात है. That's it. For that reason, we are going to take the integration from theta 1 to theta 2. P is sin theta into d theta as usually. P is constant, E is constant. Sin theta, theta is changing. Look at here. This is theta, first theta. If I am going to change, means here theta value change. If I further apply the force, means theta value is changing. Means while it is rotating, theta value is changing. That's why we need to integrate the sin theta value. If I integrate the sin theta, no, we'll get integration of, देखो इधर, PE is a constant thing, theta 1 to theta 2 sin theta into d theta. Here 2 steps I will do for your convenience, guys. Okay, then PE into sin theta को integration होता है minus cos theta. If you don't know, means try to concentrate here. Minus cos theta होता है, correct ना? And then limit we need to apply from theta 1 to theta 2. Again PE into upper limit apply करो. Upper limit means theta place में theta 2 आना है, minus cos theta 2 minus lower limit. Lower limit में theta place में theta 1 आना चाहिए, and minus value है. Minus into minus it will become plus cos theta 1. क्लियर है ना? ये दोनों चीजों को मैंने shuffle करता हूँ. Just I will shuffle. First I will write cos theta 1 and later I will write down cos theta 2. If I write like that, means there is no change will be happen. Plus will be plus होता है ये function का, इसका minus function होता है, correct ना? That's why I write that one like this. PE cos theta 1 first I will write, and then minus cos theta 2. Up to this point is understood, right, for everyone? Yes, good. Up to this point, everybody is understood, right? Good. 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 Okay. Suno either. Actually, this is the work done. What we got now here. This work done will say some other point. Actually, topic क्या है देखो एक बार. Work done on an electric dipole in an electric field. आपको already work done मिला. Work done मिला. Already in the initial class only I told you all. Guys, देखो इधर मेरे पास एक ऑब्जेक्ट है. इधर कैमरा देखो 2 मिनट के लिए. Okay, मेरे पास एक ऑब्जेक्ट है इधर. Okay, when I'm keeping this one here, it has a energy at this point. If I'm going to lift this point object here, means it has a another, means energy है, same energy है, but इसका energy value क्या हो गया, बढ़ गया. Means shall I know, may I know what kind of energy will be stored inside it? Due to change in position, what kind of energy is stored inside the object? Yes, Trupti, Yashaswini, good. I'm expecting this answer from everyone. Try to give this one. Due to change in position, potential energy आता है इसके अंदर. Correct. Means potential energy है. Okay. To gain this potential energy, yes, Sagar, good. Purnima, good. To gain the potential energy for this particle, it is moving from here to here. When I apply the force, it will be displaced. Means work done हो गया है. Due to work done, potential energy is stored inside it. In a similar way, shall I say here also work is done. When work is done in this dipole, इसके अंदर भी एक energy store होता है. Shall I say that one as an potential energy? Is it possible? Yes, potential energy है, but here potential energy we call this one as an electrostatic potential energy. We call this one as an electrostatic potential energy. Clear now? We are representing that one with the letter U. अब तक clear है ना? Electrostatic potential energy क्या है? पूछता है. Electrostatic potential energy is nothing but work done on an electric dipole when it is placed inside the uniform electric field. That's it. Cool. Right? Good. Okay, cool. And then guys, just imagine wherever the work done will come now in 12th standard, just treat this one as an energy, because work done is nothing but energy. That's why, depending upon the situation, take that one as a potential energy or as a kinetic energy or electrical energy, like that. Blah 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 extra. Okay, these are work done हो गया. Potential energy का introduction भी दे दिया मैंने. Next, I will say what is the potential energy equation. Potential energy equation थोड़ा सा change होता है. कैसे क्या है वो बोलता हूँ मैंने. Okay, देखो इधर dipole is placed in a uniform electric field at an angle θ1. Due to this θ1, if I am applying external force, means it will be displaced with an angle, small angle d theta. Due to this d theta, there is an energy which is stored inside it. We call electric potential energy, right? And then, okay, electric potential energy, we will write PE cos theta. Now you got an confusion, sir. Last slide में कुछ देखा था ना, electric field intensity will be PE cos θ2 minus cos θ1. अब क्यों कैसे आ गया सर ये इक्वेशन, है ना? I will tell you. देखो इधर, this is the initial angle θ1 dipole का. When you apply the force, means at the time it displaces with an angle d theta. This is θ1. From here it will be θ2. Okay. Here एक condition है, सुनो ध्यान से सुनो. From where we are taking, this is θ1, means this is the reference point, first point of reference. This is reference. That's why we need to take here θ1 as an 0. मान गया ना? मान लो, यही है कहानी बुक में. क्या करना है? θ1 को 0 मानना है. क्यों सर? You may be asked. Guys, whenever we are measuring the distance or whatever, we require on reference point. Okay, I'm traveling from my home to school, means reference point मेरा home होता है. इधर से calculate करते हैं आप school to home, what is the distance. In a similar way, if I want to go from school to bus stand, means you will take the reference point as a school. Reference point different होता है ना, ऐसे भी इधर भी. This is the reference point. First one है ना, θ1. This is the reference point होता है. That's why θ1 we need to take a 0. And from here, whatever the calculation will come, no, you take θ1 as a 0 itself, and you will get a correct answer also. And it will be displaced with an angle, small angle d theta, means now from here, whatever the angle is there, no, θ2. Take this θ2 as a theta itself. How much angle it is rotated? Try to keep that value inside the formula and find out the answer. Clear now? You people require one more time explanation, or it is understood to everyone? Tell me first. Next chapter will start from tomorrow onwards. Next chapter है electric flux, field line and flux, and potential, and then Gauss law, and based on the application capacitor. Yes, good. Okay, cool. Okay, we'll come to the point how this formula will come. देखो इधर work done आया था PE cos theta 2 theta 1 minus cos theta 2. मैंने बोल दिया cos theta 1 ले लो 0 and theta 2 ले लो theta itself. Okay, and then here come to the point. PE cos 0 क्या होता है? Yes, good. Cos 0 minus cos theta 2. Cos theta 2. Theta 2 is nothing but theta itself. Good, good, bro. Good decision. Right. Okay. From this equation, cos 0 means 1. Okay. Then it will become 1 is PE into 1 minus cos theta. We don't know this angle. We need to calculate actually this one only. Correct? That's why if you're going to multiply this one here means it will come PE cos theta. This is the work done, which is actually equal to potential energy. Clear enough? That's why potential energy we are going to calculate by using this formula. Minus PE cos theta. Potential energy can be taken to be zero arbitrary at any position of the dipole. That's fine. और कुछ है क्या? Yes, again same thing guys. Potential energy where it is minimum and where it is maximum we need to find out. Clear enough? Okay, if theta value will be 0, standard equation यही है. देखो इधर, this is a standard equation. Okay, from this equation, okay, potential energy if you want maximum means what will be the theta? Already इधर है sir. देखता हूँ उधर भी टाइप करता है. Yes, good. कोई प्रॉब्लम नहीं, मुझे पता है, आपको भी पता है थीटा वैल्यू. Okay, if you put cos value will maximum at 0 degree. Okay, if you put the value of 0, this energy will become maximum, that is U is equal to P into E. We call this one as an stable equilibrium position. Keep this point in your mind. We call this one as an stable equilibrium position. Okay, minimum कब होता है sir? Minimum will be at 90 degree. Right. If you put the value of 90 degree, then the value will become 0. We call this one as an minimum potential energy. And we'll come to the next point. Now देखो, this is horizontal equilibrium. 90 means minimum. If I am rotating further to 180, means exactly opposite direction. Either plus this is plus, this is minus. Okay, if I rotate like this means it will become minus, this will become plus. Means exactly 180 degree if I rotate means then cos 180 will become minus 1. Here cos 180 will become minus 1. Minus into minus plus hota hai. This value will becomes to be plus P into E. Dipole momentum into electric field. Okay, this position we called unstable in equilibrium. Why we call unstable in equilibrium? Why we call this one as a stable equilibrium? That is also very important. देखो इधर, सुनो. Yes, I will tell you. देखो इधर guys, this is my pen, okay, which is at an angle theta with the electric field. इधर electric field है horizontal direction में, theta angle ऐसा है. On this dipole, there are force will be act, coupling force will be act. And they are trying to align this one in the direction of electric field like this. If it will be aligned means the net force will become 0. Net force will become 0. And it will be in a stable point. That's it. Correct now? If I'm going to push this one in this direction means with a small angle theta, okay, what it will do? It will go in this direction and again it will comes to original position. And if I push more force means it will come to 90 degree and again it will comes to along the line direction. In the electric field direction it will come. And if I further push this one to move this dipole 180 degree means again इसके अंदर energy store होता है. But this state we call equilibrium unstable state. Means in this direction maximum potential energy होता है and also it will try to align themselves again due to the electric field. Again, it will comes to original point only, but it has a maximum potential energy in this point. That's why we call this one as an अनस्टेबल इक्विलिब्रियम, स्टेबल नहीं है इसके अंदर। क्लियर है ना? Up to this point is clear, right? Everything is sorted out. Let me know if it is clear. Means we'll move on to the problems. Good, good. Well, and I want to tell you one more point also. When we are keeping this dipole in an external field, no, force value will become 0. Okay, but torque value is not equal to 0. Always, not always, not always. Okay, torque value may be 0. Okay, may not be 0. How to say this one means torque equation है ना, PE sin theta इधर से. If sin 0 will be 0, at the time torque will become 0. Correct now? But sin theta is maximum means 90 degree. At 90 degree, torque will become maximum PE. For that reason only, torque value not equal to 0 in a external magnetic field when we keep the dipole momentum. Dipole. F is equal to 0 y. अयो अरे तृप्ति कहाँ है आप? देखो इधर कहाँ चला गया? This is dipole minus q charge plus q charge. हाँ, I will tell you. Okay, this is electric field. Okay, due to electric field on this plus q charge, force will be acting in this direction. Due to negative charge, force will be acting in this direction. Okay, ये दोनों force same ही है, same amount of force, because uniform electric field first point and then charge magnitude second point. Net force क्या होता है? Net force means F1 plus F2. Good, I will tell you. Okay, if someone will be don't know means you maybe you will get one more time. That's fine. Okay, F1 is in this direction, F2 is opposite to that one. That's why I will write F1 plus of minus F2. Hence, these two will be cancelled. Net force will be become 0. That's why always, this is always, not only any case, it is always. Cool now? And meanwhile, guys, if you are getting any doubt, no, please let me know in the chat box. Cool. Okay, I will try to reach out to you all. Okay, other question ali problem madbidi. Sorry, in a same Josh, try to solve this problem. Okay, problem क्या है? देखो, I will give you exactly 2 minutes after this one. You have to solve this one. Two charges plus or minus, अरे यार, two charges plus or minus 1000 microcoulomb are separated by 2 millimeter distance. The dipole so formed held at an angle of 30 degree. एक dipole है, उसका charge भी दे दिया है. Dipole में charge होता है उसका magnitude. They are actually held at 30 degree में held किया है. With a uniform electric field, sorry guys, E value will be 15 into 10 to the power of 4 Newton per coulomb. Okay, calculate the torque acting on it. Torque को calculate करना है. क्या क्या दिया है लिख दो इधर. Charge will be plus or minus 1000 microcoulomb and their separation distance 2L दे दिया है 2 millimeter. Angle दिया है 30 degree and then electric field intensity दे दिया है 15 into 10 to the power of 4 Newton per coulomb. Okay, it's the simplest problem. It is not any competitive problem. Okay, try to solve this one and tell me the answer. Great, Purnima. Right answer. If you are not writing SI unit, means you might be lost the mark in a board examination. Okay, try to mention the SI unit. Good. अरे यार, टॉर्क पूछा है ना, सिंपल है, टॉर्क इज इक्वल टू पीई साइन थीटा। इसमें क्या है, पी कैलकुलेट करना है आपको, करेक्ट है ना? हाँ राइट इट्स p value they didn't give, you have to calculate the p value. How to calculate the p value? This charge into distance of the separation distance of the dipole into electric field value they given, no, 15 into 10 to the power of 4 into sine 30 degree they given. This is enough, right? Charge, either you take plus or minus, only you have to take the magnitude, that's it. Means 1000 into 2l distance, how much they given? 2 millimeter, means it will be 2 into 10 to the power of minus 3 meter into this one will be 15 into 10 to the power of 4 Newton per coulomb into sin 30 value कितना होता है? 1/2, 1/2, right? हाँ सॉरी वन मोर पॉइंट, हियर मैंने 1000 लिख दिया, उसके आगे भी कुछ दे दिया है वो साहब, करेक्ट ना? उसको भी लिखना है हमको इधर, सॉरी। ओके, 1000 microcoulomb they said. They're saying here 1000 microcoulomb means 1000 micro means 10 to the power of minus 6. Yes, Trupti, right. इधर 1000 है ना, shall I write this 1000 as 10 to the power of 3? Simple सा है. And meanwhile, guys, please do after I will say after this problem. Okay, 10 to the power of 3, 1000, and then either 10 to the power of minus 6 as itself into, इधर देखो this two cancel हो गया, मैं क्या कर सकता है, and then 10 to the power of minus 3 here into 15 into 10 to the power of plus 4. देखो इधर this minus 3, this plus 3 cancel, power में and ratio also. Remaining will be minus 6 plus 4, it will be minus 2. यशस्विनी देखो एक बार, सिंपल से मिस हो गया आपका प्रॉब्लम। सागर वेरी गुड ब्रो, यूनिट लिख दो यार सागर, ट्राई टू राइट द यूनिट। ओके, इट विल बी रिमेनिंग हियर 15 into 10 to the power of, ये दोनों पावर ऐड कर लो, ओके, minus 2, टॉर्क मींस न्यूटन मीटर। Okay, now this is the answer, torque. Or else if you want to write in a simplified answer means a 10 to the power of minus 2 means divided by 100, we can write this one as a 0.15 न्यूटन मीटर। सर कहाँ से आ गया सर टॉर्क के लिए ऐसा यूनिट न्यूटन पर मीटर? अरे यार, टॉर्क इज इक्वल टू फोर्स इनटू परपेंडिकुलर डिस्टेंस, फोर्स मींस न्यूटन, परपेंडिकुलर डिस्टेंस मींस मीटर, ऐसा यूनिट। क्लियर है ना, ये सबको क्लियर है ना? चैट बॉक्स में बोलो एक बार, जय अवंती बोल दो। Good, cool. Thank you, Sujan. Okay, guys, please do participate in this NPS poll meanwhile. Okay, Sagar. Hey. Cool. We'll move on to the next problem. देखो इधर और एक प्रॉब्लम है, क्या है प्रॉब्लम? फाइंड द टाइम पीरियड टी ऑसिलेशन इन अ डाइपोल। गाइस, लाइक दिस चैप्टर से ना, इसके अंदर बहुत मैकेनिक्स इन्वॉल्व होते हैं। ओके, ट्राई टू सॉल्व लाइक दिस प्रॉब्लम ओनली व्हेन यू आर इन अ फ्री टाइम। ओके, नाउ देखो सेम तरीका है, डाइपोल है। ओके, डाइपोल वी आर कीपिंग दिस वन इन एन एक्सटर्नल इलेक्ट्रिक फील्ड। ओके, कूल, एंड देन थीटा एंगल से वो ऑलरेडी इंक्लाइंड है। Okay, if I'm going to apply some force means it will make some angle d theta, d theta करता है, ऐसे हो गया in this direction d theta. Okay, after removing the force, it will be come back to its original position again. And applying force होता है ना, it is a restoring force होता है इसके अंदर. Due to restoring force, it will make one oscillation like this. Oscillate करता है ऐसे. Oscillate कर रहा है means guys, to make one complete oscillation, what will be the time period of it? We need to calculate. देखो, interesting facts will come from this point. Right now, this is exactly that concept only. To find the time period t of an oscillation of dipole. Oscillation कैसे होता है पता हो गया ना? When you're going to apply the force on this one, no, it will go here. After remove the apply the force, it will comes to in this place like this. It will be oscillate. Correct now? While it is oscillating, to complete one oscillation, to move upside and come side, it will take some time. That is the time period. They are asking that what is the time period? Simple सा, मैंने बोलता हूँ कैसे कैलकुलेट करना है सब कुछ. ओके, देखो इधर, दिस इज जेई क्वेश्चन. Honestly, I'm saying this is a JEE question. Okay, time period का वैल्यू होता है 2 पाई बाई ओमेगा. आप सबको पता है ना सर, ये कहाँ से आ गया सर, पूछ सकते हैं. सिंपल है वे यार. ओके, कैसे आपको पता है, वेलोसिटी और स्पीड इज इक्वल टू डिस्टेंस बाय टाइम टेकन. Time if you want to take here means it will become distance by velocity. This is for linear. Okay, if I'm going to talking about the circular motion means point object A में था, if it is moving to point B means displacement हो गया theta. Correct now? If it is completely displacement for a complete round means for angular displacement value will be 2 pi. This is the displacement or distance. Displacement ले लो, कोई problem नहीं. Okay, which is completing the one complete round means with an velocity. Here we call angular velocity as an omega. That's it. Here in this equation I will changing like this. Okay, time period को complete round वो complete करने के लिए time लेता है ना, उसको मैंने बोलता हूँ time period capital T. and displacement हो गया कितना 2 pi divided by velocity. इधर velocity है ना, velocity here omega. Got you right? How the equation came? Did you got right how the equation came? T is equal to 2 pi by omega. Yes, good. Now time period calculate करना है. Time period होना है means we need omega. Omega के अलावा कुछ भी नहीं हो सकता है इधर. Okay, omega calculate करने के लिए एक equation होता है guys. Okay, omega के लिए क्या है सर वो इक्वेशन? सिंपल, एक्चुअली एक्सेलरेशन वैल्यू विल बी माइनस ओमेगा स्क्वायर एक्स होता है. लीनियर एक्सेलरेशन लिख दो, इसको लिख दो. इफ यू डोंट नो मींस राइट डाउन. ओके, दिस इज फॉर लीनियर एक्सेलरेशन. लीनियर एक्सेलरेशन नॉट लाइक दैट, एक्चुअली इट विल कम इन अ वेयर ऑसिलेशन चैप्टर में आता है, ऑसिलेशन एंड वेव्स इन दैट चैप्टर. ओके, I will derive this one in the end of the class if I am getting a time means. Okay, no worries. Okay, if I'm going to convert this one for angular acceleration means alpha, a के place में alpha replace करना है, omega square as itself, and x means it's a displacement. Here displacement will be theta. That's it. That's it. Okay. Next we'll come to the point. देखो कैसे कैलकुलेट कर सकते हैं. इधर टॉर्क भी अप्लाई हो रहा है. Correct now? Torque is equal to PE sin theta, right? For a small angle, theta is small means, okay, we can take sin theta as an theta itself. Theta itself means torque value will become PE theta. Shall I write like this? सुनो ध्यान से सुनो, अच्छा क्वेश्चन है. Okay, then here I told you that restoring force is acting. Yes, good यशस्विनी. Restoring force is acting means force के लिए एक इक्वेशन होता है minus kx means force will be negative to the displacement we will say. That's why I will write here torque as an minus PE theta. Means if you apply the force in this direction means displacement will be होता है वो क्या है ना, स्प्रिंग है मान लो, स्प्रिंग है. स्प्रिंग क्या if you apply the force on this direction means स्प्रिंग के ऊपर. ओके, दिस इज एक्सटर्नल फोर्स. स्प्रिंग के अंदर फोर्स इधर होता है, स्प्रिंग फोर्स. डिस्प्लेसमेंट इधर होता है. means opposite direction. That is what restoring force. I'm talking about the restoring force. That's why torque also you are executing restoring force. Clear? Next point सुनो. Torque के लिए equation होता है I alpha, okay, is equal to minus PE theta. I alpha, where it will come from is system of particle and rigid rotation में concept है. Sorry, if you know means it is good. Okay, no need to worry. Try to analyze everything which we will feel new concept. No, try to note down those points. These are all the trick point for your examinations. Okay, torque equation होता है हाई अल्फा. सर कैसे सर? देखो इधर F is equal to mass into acceleration ना. Similarly, torque value will be m r square. Sorry, I alpha will write. I will tell you what is this. If you want to remember, means like this only you have to remember. कैसे? देखो, force means linear force. उसका rotating force क्या होता है? Torque होता है. Good. Alpha means linear acceleration. उसका rotating means angular alpha acceleration क्या होता है? Alpha होता है. Good. Mass means mass only. Mass को replace करना वाला कौन है? Inertia होता है. Moment of inertia. Yes, that's good. That's good, Trupti, Yashaswini, and so many of you people are giving an answer. Great, great. Okay, that's why I replaced this one. Already we find out the alpha, no? Alpha value पता दिया था. उसको इधर substitute करो. I into alpha means minus omega square theta is equal to minus PE theta. Minus minus cancel la. This theta cancel la. Take I to right hand side. Then omega square is equal to PE by I. Yes, simple harmonic motion. Okay, then omega square is there. If you want omega means take under root right hand side, then it will become PE by I. Omega आ गया. हमको कैलकुलेट करना था टाइम पीरियड. टाइम पीरियड इज इक्वल टू 2 पाई बाय ओमेगा. ओमेगा प्लेस को इधर रिप्लेस करो, देन यू विल गेट टाइम पीरियड इज इक्वल टू 2 पाई डिवाइडेड बाय अंडर रूट ऑफ PE बाय I. इसको ऊपर लेके आने से आता है 2 पाई अंडर रूट ऑफ I by PE. Guys, this is a JEE mains question. Try to solve the questions like this. Okay, previous year question है, but थोड़ा सा concept mix हो गया. That's it. Understood, right? How I solved? Once you will get a good grip over the concept, then you will along the problem in an easy way. Okay. All right. Is it understood right for everyone? Yes, good Trupti, good Sujan, good Ashwini. Right Niranjan. Okay. और एक सिंपल कॉन्सेप्ट क्वेश्चन पूछता हूं मैंने, उसके बाद सेशन एंड करते हैं. ओके, कॉन्सेप्ट क्वेश्चन क्या है ना, देखो इधर. दिस इज अ क्वेश्चन, सुनो ध्यान से सुनो. दिस इज आल्सो जेईई क्वेश्चन. फिगर शोज ट्रैक्स ऑफ 3 चार्ज्ड पार्टिकल्स. ये फिगर में 3 चार्ज्ड पार्टिकल्स का ट्रैकिंग किया है. यूनिफॉर्म इलेक्ट्रोस्टैटिक फील्ड, इसके अंदर यूनिफॉर्म इलेक्ट्रिक फील्ड है. यूनिफॉर्म इलेक्ट्रिक फील्ड कैसा है? एक्चुअली पॉजिटिव चार्ज से स्टार्ट होता है, नेगेटिव चार्ज की तरफ एंड होता है. इट्स एन यूनिफॉर्म. गिव द साइन ऑफ द 3 चार्जेस. मींस इधर 1 2 3 चार्जेस आर देयर. दे आर एक्चुअली मूविंग इन दिस इलेक्ट्रिक फील्ड, यूनिफॉर्म इलेक्ट्रिक फील्ड. नाउ वी वांट टू नो व्हाट विल बी द चार्ज ऑफ 1 2 3. फर्स्ट चार्ज का वैल्यू क्या, मींस वेदर इट इज नेचर चार्ज क्या है, पॉजिटिव चार्ज या नेगेटिव चार्ज. दे आर आस्किंग. टेल मी वन बाय वन व्हाट आर द चार्जेस. फर्स्ट चार्ज क्या बोलता है, सेकंड चार्ज क्या है, थर्ड चार्ज क्या है. फर्स्ट विल डिस्कस अबाउट द चार्जेस. साइन ऑफ द चार्ज. अरे यार गुड प्रतीक, गुड पूर्णिमा. Good. Okay. Obviously, if a charge is moving towards the positive potential plate, means obviously it should be a positive charge. This is also slightly it is moving, but it is far away. इसके ऊपर बहुत कम फोर्स लगता है due to this charge, इसलिए थोड़ा बाहर आ गया है. But it is also positive charge. This is also positive charge. Correct now? And this third charge is moving towards the negative potential plate, means that's why it is opposite kind of the charge, means it will be a positive charge. Clear enough? Right, Jane? Right. Good, good. Okay. इसके साथ साथ मुफ्त में और एक क्वेश्चन दे दिया है, देखो इधर, which particle has the highest charge by mass ratio? Charge by mass ratio means E by m value is highest for which particle? 1, 2, 3. Tell me. First is positive, second is positive, third is negative. Okay. Highest mass by charge ratio. Yes, Polma, right. Good, Trupti. Good, Kodagu. Right, Yashaswini. Highest charge by mass value will be for the 3. How means? Either charge value will be either positive charge means 1.6 into 10 to the power of positive. Sorry. Okay, this is negative. Third one is positive. Positive charge के लिए okay. Now it is good. Positive charge के लिए इतना आ रहा है. Negative charge means charge by mass ratio. For the negative charge, charge value same 1.67 into 10 to the power of minus 19. By mass of the negative electron will be 9.1 into 10 to the power of minus 31 होगा. If it is comes to numerator means again इधर देखो, इसका भी कुछ आता है, उस उधर ही रख दो, कोई प्रॉब्लम नहीं. Something what I don't want to write this one x value into 10 to the power of minus 19 into 10 to the power of plus 31. It will be around dash into 10 to the power of 11. हाँ, plus 11 आता है. Means negative charge का charge by mass ratio will be maximum. Right? Absolutely right. Sagar right. हाँ, 8 minus 8 plus 8 bro. Sagar cross check करो एक बार. Okay, इसके साथ साथ guys first chapter खत्म हो गया. We'll start the second chapter from tomorrow onwards. Electric flux and then potential and its application with a gas lamp. Okay, hope it is understood to everyone. If you had any doubt means you may be you ask in a chat box or else I will unmute you all. You may talk with me. That's it. Okay, this is all about today's class. If you don't have a doubts means you can leave also. No problem.
Sir. Hello.
Just a minute. Hello. Goodbye. Hello.
Sir, tomorrow I will start electric flux.
Bro, may I know who is this? Captain.
Yes, sir.
कुछ आपका नाम बता दो यार. Your good name. Yes, कोई problem नहीं. We'll start the electric flux will start from tomorrow onwards. Okay. Right. Okay, guys. Bye bye. Bye, Shaswini. ವಂದನೆಗಳು. Thank you, Trupti. Thank you so much. Bye. Bye, Sujan.